All right, take a look around you for a second. The phone you're holding, the car parked outside, even the very device you're watching this on right now. They all share this deep, hidden secret, a foundation built on code that's, believe it or not, half a century old. So today, we're going to pull back that curtain and take a look at the code that built our world, the C programming language.
So think about that for a moment. You've got a super complex computer operating system, a smart TV, and the little computer that runs your car's engine. I mean, on the surface, they seem like they have absolutely nothing in common, right? So what's the invisible thread that ties all of them together?
Well, the answer is a language called C. Yep, a programming language that's been around for 50 years, and it's still the bedrock for so much of our modern world. It's not flashy, it's not the new cool kid on the block, but it is, without a doubt, one of the most important building blocks of our entire digital age.
Okay, so if we want to understand how our digital world is actually put together, you really have to start with C. Let's dig in and figure out what it is and why on earth it's still everywhere.
So C was born way back in the early 1970s, created by a guy named Dennis Ritchie at Bell Labs. Now, there are two key ideas here you really need to grasp: structured and general purpose. Structured is kind of like building with Legos, right? You use these nice, organized, predictable blocks to build something really complex. And general purpose? Well, that just means it's not a tool for just one job, like a hammer. It's the whole toolbox. You can build pretty much anything you can dream up with it.
And that combination is really its secret sauce. First off, it's ridiculously fast, and that's because it speaks a language that's super close to the computer's own native tongue. Second, it's incredibly powerful. It gives programmers this almost unheard of level of control right down to the bare metal, the hardware itself. And third, it basically became the blueprint, the common ancestor, for a ton of the major programming languages that we use today.
Okay, so what's actually in this toolkit that C gives to developers? What are the specific features that made it the absolute go-to language for so many critical jobs for decades and decades?
All right, this really breaks down C's superpowers. You've got portability, which is a huge deal back in the day. It meant you could write your code one time and then run it on all sorts of different computers. Revolutionary. But the two real game changers are these. First, memory management. C basically hands the programmer the keys to the computer's memory. You can manage it directly, which gives you incredible speed. And second, it's what we call a mid-level language. Think of it as the perfect translator, bridging that low-level world of computer hardware with the high-level world of the software we use every day.
So where do we actually see this toolkit in action? Well, pretty much everywhere. I mean, literally. The very core of operating systems like Windows and Linux? Yep. That's C. The tiny little computer running your microwave or your smart thermostat? That's C too. Even the compilers, the tools that translate other programming languages into code a computer can understand, are often written in C. It truly is the invisible engine powering our world.
But, that much power doesn't just come for free. C gives programmers an incredible amount of control. But with that control comes a huge amount of responsibility. It's a classic trade-off. Let's take a look.
This really captures the whole philosophy of C perfectly. On one side, you get all this amazing power. We're talking raw speed and features like pointers, which are basically direct addresses to specific spots in the computer's memory. But the price you pay for that power is that you have to manage all that memory by yourself. Think of it this way. Most modern languages are like cars with automatic transmissions, lane assist, all the safety features. C is like a manual transmission race car with no seatbelts. It is ridiculously fast, but if you make one wrong move, there is absolutely nothing there to save you. So after 50 years of all this power and all these pitfalls, what's C's ultimate legacy? How does it still shape the future of tech, even as all these new languages are popping up all the time?
I mean, this quote just sums it up perfectly. Despite how old it is, C's core strengths, that raw speed, efficiency, and control, mean it's just not going anywhere. Think about something like high-frequency stock trading or the core engine of a massive video game. In those worlds, every single nanosecond counts. And in that arena, C is still the undisputed king.
And, maybe its greatest legacy of all is its children. So many of the languages you hear about today, like C++ or Java or even Python, were either built directly on top of C or were heavily inspired by its structure. Learning C is kind of like learning the Latin of programming languages. Once you know it, you start to see its DNA absolutely everywhere.
And this brings us to one last really crucial thought. In a world where AI is starting to write our code for us, where everything is becoming more high-level and abstract, does it still matter? does it still matter to understand what's happening underneath it all, to really get how the machine works at its core? C represents that foundation, and the fact that it's still so relevant today, well, it really forces us to ask ourselves, what do we lose when we forget how things are truly built?